Hey, welcome to The Explainer. Today we're going to talk about something that's literally all around us, every single day: probability. It's really just a powerful way to think about and make sense of a world where, let's face it, pretty much nothing is guaranteed. So, how do we navigate all that uncertainty? Let's dive in.
Just stop and think about it for a second. Is anything really a sure thing? From the moment you wake up, you're playing the odds. Is traffic going to be a nightmare? Will your favorite coffee place still have that croissant you like? All this uncertainty. It's exactly why we need a clear way to talk about chance.
And look, it's not just the small stuff. Some of the most important decisions we make are all about managing uncertainty. We're talking about forecasting the weather, trying to predict the stock market, making sure the products we build are safe and reliable, or even just planning a huge project. Being able to understand probability, that's a genuine superpower.
Right, so to get a real grip on all this randomness, we need to be speaking the same language. So let's start at the very beginning with the basic building blocks, the core ideas that let us talk about chance in a really precise way.
Okay, first up, we have what's called an experiment. Now, don't just think about lab coats and bubbling beakers here. In probability, an experiment is basically any action where the result is uncertain. Flipping a coin, that's an experiment. Rolling a die, experiment. Launching a new app? You got it. It's an experiment. You know what could happen, you just don't know for sure what will.
So if the experiment is the action, the sample space is just the complete list of everything that could possibly happen. It's that simple. For that coin toss, the sample space is just heads and tails. That's it. That is the entire universe of possibilities for that one specific action. And that brings us to the event. An event is simply the outcome, or maybe a group of outcomes, that we're actually interested in. It's the piece of that sample space that we care about. So in our coin toss, the event might be the coin landing on heads.
Okay, let's make this feel a bit more real. Imagine we're doing quality control, and we test 3 units from a production line. D means it's defective, G means it's good. This table right here shows every single possible combination. So this entire list of 8 results, that's our sample space. Now let's say the event we're watching for is getting exactly 2 defective units. Well, we can just scan our list and see, yep, that corresponds to outcomes 2, 3, and 5. See? By mapping out all the possibilities, we can pinpoint the exact event we need to analyze.
All right, so we know how to define what we're looking for, but how do we actually put a number on it? How do we calculate the probability? Well, it turns out there's no single one-size-fits-all method. The best way to do it really depends on the situation. You can think of it like looking at the problem through 3 different lenses.
The first one is probably the one you're most familiar with. It's the classical approach. This is perfect for things like fair coins, dice rolls, or drawing a random card. The key idea, the absolute deal breaker, is that every possible outcome is equally likely. So if you're drawing a number from 1 to 9, the chance of getting the number 4 is just one favorable outcome out of 9 total options. Simple as that. 1 in 9.
But what if things aren't so perfectly balanced? That's where the relative frequency approach comes in. This one is all about using past data. Let's say a newspaper seller wants to know the odds they'll sell over 100 copies tomorrow. They can just look back at their sales records for the last year. The probability is simply the number of days they did sell over 100 divided by the total number of days they kept records. It's all based on historical performance. So what do you do for totally unique situations, the one-offs, where there's no past data to look at? Imagine trying to estimate the chance of success for a brand new cutting-edge solar power plant. You can't roll a die for that, and there's no history. This is where we have to use the subjective approach. It's where an expert uses their experience, their intuition, and all the available information to make an educated guess. It's a judgment call, but sometimes it's the only tool you've got.
Okay, so we've got our basic tool set. But let's be honest, the real world is messy. Things aren't always so neat and tidy. Events overlap, they influence each other. So the next step is figuring out how to combine these simple probabilities to answer much harder, more complex questions. Let's dig in.
Let's kick things off with something called the addition rule. So say you want to know the probability of drawing an ace or a spade from a deck of cards. Your first instinct might be to just add the probability of getting an ace, that's 4 out of 52, to the probability of getting a spade, 13 out of 52. But hang on, if you do that,
You've actually counted one card twice, the ace of spades. It's both an ace and a spade. So to get it right, we have to subtract that overlap. We subtract the probability of getting the ace of spades, which is 1 in 52.
And that little wrinkle leads us to one of the most important and, frankly, coolest ideas in probability. It's called conditional probability. And it's not about the odds of something happening in a total vacuum. It's all about this question: how do the odds of something happening change, given that you know something else has already happened? This example makes the difference crystal clear. So on the left, we ask a simple, unconditional question. What's the probability a randomly chosen person from this group of 5,000 is over 30? Simple calculation. It's 24%. Okay, but now look at the right. We get a new piece of information. We are given that the person we chose is a female. The entire question changes. Our universe of possibilities has shrunk from 5,000 people down to just the 3,000 females. And within that new, smaller group, the probability of being over 30 plummets to just 6.7%. See, that single piece of new information totally changed the odds.
This whole idea of updating our odds when we get new information, it's not just some neat little mental trick. It's actually a formal process. There's a famous mathematical rule for this, one that gives us a precise way to change our minds, to formally revise our beliefs when new evidence comes to light.
Let's just walk through a classic example. So a manufacturer has an initial belief, let's call it a prior probability. They believe their machine is set up correctly about 60% of the time. That's step one, their starting point. Then in step two, they get some new evidence. They run a test, and the very first part that comes off the line is defective. So now, the big question is, how should this new, frankly bad piece of news change their initial 60% confidence? And the result is, well, it's stunning. After we crunch the numbers, the belief that the machine is set up correctly just plummets. It goes from 60% all the way down to 20%. Now, why such a dramatic drop from just one bad part? Well, think about it. A defective part is way more likely to come from an incorrectly set up machine, right? So seeing a defect is actually very powerful evidence that points away from our initial belief that everything was fine. This is basically how we learn from experience, but captured in math. Wow. Okay, so we have covered a lot of ground here. We started with the basic building blocks: experiments, sample spaces, events. We looked at the different ways to calculate probability. And we ended with the incredible power of updating our beliefs based on new data. So what's the big takeaway from all this?
At the end of the day, probability is so much more than a bunch of formulas in a textbook. It's really a framework for thinking. It's a structured way to make smarter choices, to manage risk, and to just see the world a little more clearly. A world that is never going to be 100% predictable.
And that's where we'll wrap it up. So I'll leave you with this one question to mull over. Thinking about your own life, a project at work, a financial decision, maybe just planning your weekend, what uncertainty could you start to see a little bit differently now? Thanks for watching.